For this lesson, what we're going to do is just pretty much more practice of the same basic thing. So, what are we going to do with this one? We're going to move the tangent. We want to isolate the cosine x. So we have 5 cosine of x equals negative 4. Cosine of x equals negative 4/5. Next step is what? Everyone should be saying this at the same time. This is draw the unit circle. Cosine is the x on the unit circle. We want x equals to negative 4/5. So we'll go somewhere about 4/5 of the way. There's negative. We can see that there are two solutions. Are those unit circle values? No. So we're going to write inverse cosine of negative 4/5. Do that on your calculator, and you get approximately 2.50. Remember, if we're going to 2 decimal places, the hundredth, you need to actually write that 0 down. Now, how do I find that other angle? There's 2.50, here's 2.50, and I want to go all the way around. Well, the other angle plus 2.50 makes 2 pi, so I can go 2 pi minus 2.50. Now, on your calculator, actually type in 2.5 minus, or 2 pi minus answer. Don't use 2.50. It's a hit and miss whether you would get it right or not. And this gives us 3.79. Find the angle of inclination. So what do we need to do? On the last lesson, we said that the angle of inclination, the tangent of the angle of inclination equals the slope of the line. So let's find the slope of the line. Does it say we have to graph? No. So let's, if you want to, you can. For this particular problem, I'm going to show it just to confirm what's going on, but it's not required. Tangent of alpha equals negative 3/4. Type that in so we get alpha equals the inverse tangent of negative 3/4. Remember that you have to change your mode. So I'm going to move my calculator back to degree mode. And I would have inverse tan negative 3 divided by 4. And you get negative 36.9 degrees. Does that work? No, because we were told yesterday that, or last class, the angle has to be between 0 and 180. Let's take a look at what's going on here. We have a positive y-intercept and has a negative slope. This is my angle that I'm looking for. That's alpha. What did the calculator give me? Remember, the inverse tangent, the range of values for that is negative 90 degrees to 90 degrees. So what it gave us was this angle. What can I say about the angle I'm looking for and the one the calculator gave me? They add up to 180. So what we want to do is say plus 180. So on your calculator, just hit plus 180, and it then says answer plus 180. So we get this answer is 143.1 degrees. Now here's a slight variation of it. Find the equation of the line if you're told the angle alpha is 135 degrees and we have a point. So we can say the tangent of 135 degrees, and since you're all experts in the unit circle, you know 135 degrees is in the second quadrant. It has a reference angle of 45. So tan of 45 is 1, and in the second quadrant, tangent is negative. So that tells us, and I should have put m equals, that's my slope. And now I can say y minus y1, which is negative 6, equals negative 1 times x minus 4. And the only thing I would simplify is to say y plus 6. And that's it. Now we look at the next piece. Now we're just going to be solving equations. We're going to relate it back to the kind of things we've done before. We're trying to isolate the secant here, our trig function, so it means we have to get rid of the absolute value. So we get secant x equals plus or minus the square root of 2. Let's change secant into 1 over cosine equals plus or minus root 2. Remember, I went over this one last class. If two fractions are equal, their reciprocals are equal. So the cosine x equals plus or minus 1 over root 2, which is plus or minus root 2 over 2. So we have two equations, cosine x equals negative root 2, or cosine x equals positive root 2. What's the next thing we should do? Unit circle. We have negative root 2 over 2 is about negative 0.7, and we have about positive 0.7. So we have a bunch of answers here. Now what are these answers? This first one, x equals pi over 4. And then we have 7 pi over 4. Those are the solutions to the positive side. And on the negative side, x equals 3 pi over 4 and 5 pi over 4. Now, what if there's no restriction on x? That would say that it's all four of these, plus 2 pi n for each one of them. Now, that's good, and we could write that, but that's a lot of writing. What do you notice about the difference here? And it might be easier for you to see if it is in degree mode. I don't know, though. From pi over 4 to 3 pi over 4 is 2 pi over 4. From 3 pi over 4 to 5 pi over 4 is 2 pi over 4. From 5 pi over 4 to 7 pi over 4, 2 pi over 4. 7 pi over 4, and then up to this angle there would be another 2 pi over 4. So they all have the same difference between there. So x can be written as pi over 4 plus 2 pi over 4, which is just pi over 2 n, where n is an integer. Let's take a look at the next one. We haven't dealt with logs in a while. Remember, the base of our log becomes the base of an exponential when we transform it. So cosine of x equals 2 to the negative 1, or in other words, 1 over 2. We look at our unit circle. Cosine equals a half, so that's x equals 1/2. What are those two values? X equals pi over 3 and 5 pi over 3. And pretty much this assignment is just going to be more practice like this. You getting reviewing some material as well as kind of combining them together with this trig function stuff.